Okay, now we shall start modeling the fluid domains. Right click geometry and choose new design modeler geometry. Design modeler is open. Choose XY plane, right click here and choose look at. Now go to sketching. We shall draw the pipe domain first. Let us change the units to millimeters. Okay. The pipe diameter is 15 mm and the length is 500 mm. We shall draw a circle here. We shall specify the dimensions. The diameter is 15 mm. Okay. You can go back to modeling and click extrude. Select the sketch. Okay. And enter the distance as 500 mm. Click generate. The pipe model is generated. Next we shall generate the external model. Now click XY plane and select new sketch. Click this icon. It will create a new sketch. Now click the sketch and go to sketching mode. Right click, look at. Here you can draw a rectangle to specify the external domain. Now specify the dimensions. Vertical dimension between these two horizontal lines. The domain details are given here. The height is 300 mm and the width is 500 mm and the distance between front face and the pipe is 150 mm. Overall length is 800 mm. This will be 300 mm. The distance between center line and the top line is 150 mm. The overall width is 800 mm. Okay. Here the diameter is 15 mm. So I am giving approximately 10 diameter distances on the front, top and bottom sides. In the rear side we can give approximately 20 to 30 diameter distance. Let us go back to modeling. Click extrude and select the second sketch. Click apply. The overall length is 500 mm. Here make sure to change the operation to add frozen. Then it will be two different domains, or else both the pipe and fluid domain will get united together. We have to choose add frozen here, right click and click generate. Now two domains are present. One is the internal pipe and another one is the external pipe. But here the external pipe is completely filled and there is no cylindrical portion at the center. So now we have to choose boolean and subtract the inner portion. Go to create, boolean, choose subtract. The target body is the outer domain and the tool body is the inner pipe domain. You can select from this extrude, apply, or you can select from the solid, apply. The target body is the full rectangular domain and the tool body is the inner pipe domain. Here you have to choose yes for this preserve tool bodies. Then only the tool body will be preserved, or else it will be deleted. Now right click and click generate. Now two solids are created. One is the internal one and the other one is the external one. Here you can see it is having a hole at the center. We can hide the solid body and see the external domain. We can see it is having a hole at the center. We can click this and show body. Now there are two domains and there is a common interface between these two domains. Next let us create the named selection for this. Choose face filter, right click the inlet face and create named selection. You can mention the name as inlet. Similarly choose the rear face, right click and select. We have to first generate this. Next choose the rear face, right click and choose named selection. Enter it as outlet. Click generate. Next choose all four outer walls. Right click, named selection, mention it as wall. Click generate. Now you can hide the external body and give the named selection to internal body. Right click this inlet face, choose named selection and type pipe inlet. Select this cylindrical surface, named selection. We shall generate this first. Right click, named selection, pipe wall, generate. Next we shall specify the name for outlet region. This will be pipe outlet. Okay, now both the domains are created and the names have been specified for the regions. We can right click and show all bodies. Okay, next we shall create the mesh for these two domains. Let us come back to Ansys workbench. Right click mesh and click edit. The model has been imported. Let us rename the domains. If you expand this geometry, you can find two domains in the name of solid. We shall click this and rename it. Press F2. This is the pipe domain and the other one is the outer domain. The names of the other regions are specified in the design modeler. Now we shall start specifying the mesh parameters. Click this mesh. We shall specify the default element size as, by default it is 50 mm, close to that. We shall specify it as 20 mm. We can see the crosshair size. This should be fine for this domain. Next we shall specify the size for the pipe as well as the interface regions. Right click mesh, insert, go to sizing. Here you can select the geometry. You can select by direct selecting or choose by named selection. Now we shall hide the outer domain and select the pipe domain. Come back to sizing, click the geometry, choose body selection filter, apply. Let the element size be 1 mm. Since it is a pipe, we have to give finer elements inside. So the 1 mm size will be approximately corresponding to this crosshair circle size. Okay. Next we shall specify the size for the pipe interface. Now you can show the outer domain, hide the pipe domain. Right click mesh, insert, sizing. Here we shall select the face filter and select the inner cylindrical face. Click apply. Let this be 1 mm. Okay. Next we shall specify the multi-zone regions. Insert, method, select this outer domain geometry, apply and choose multi-zone method. Here you can specify the source. Click manual source and select the side face as source. It will be sweeping to the other end. And here you can specify the element size for sweep. Element size can be around 10 mm here. The overall width is 500 mm. So if we specify 10 mm, then there will be 50 elements in this width. Next we shall specify the same for the pipe domain. Right click mesh, insert, method. We can show the pipe domain and hide the outer domain. Select the geometry, apply, use multi-zone, select the source face, apply, let the element size be 10 mm. Okay. In both outer domain as well as pipe domain, you have selected the sweep element size as 10 mm. Okay. Next we have to specify the inflation layers. We have to specify inflation for internal flow as well as external flow. So right click mesh, insert, go to inflation. Select the geometry and then select the face. This is the boundary. Apply. We shall specify the first layer thickness. We have calculated the first layer thickness as 0.05 mm for y plus is equal to 0.3 condition. 0.05 mm. We shall specify 5 layers inside and let the growth rate be 1.4. Okay. Next, right click mesh, insert, inflation. Now you have to give inflation to the external domain. Right click outer domain, show body, hide the inner body. Come back to inflation 2, select the whole geometry, apply. Now select the boundary. That is the cylindrical surface. Click apply. We can specify the same y plus and first layer height. It is 0.05 mm. Let the maximum layers be 10 layers here. Since it is going out of the domain, we can increase it. And the growth rate be 1.4. Okay. Now we have specified all the conditions, that is overall mesh size 20 mm, body sizing for the pipe domain 1 mm, and face sizing for the interface region in the external domain as 1 mm, and the multi-zone sweep which is 10 mm for both external domain as well as internal pipe domain, and inflation has been specified for the pipe domain as well as external domain. You can right click pipe domain and click show body. Okay. Now right click mesh and generate it. Now mesh has been generated. You can zoom and see. Inflation is present in the inside as well as outside. Other regions are having hexagonal mesh. Okay. We can come back to the statistics and check the overall number of elements. It is close to 95,000. Okay. Now meshing is done. We shall go to CFX preprocessor. Come back to Workbench. Right click mesh and click update. Mesh has been updated. In the next lecture, let us create the setup for this domain. Thanks for watching this video. I will see you in the next lecture.